Well, taking a step back, the concept of a BOM, a bill of materials, is well known and you're probably very familiar with from maybe more traditional manufacturing, if you like. It's part of a standard supply chain management. It's a document that basically is a list of all the different components and parts that are in a final product. So here we have a car, and we can see that we've got different components from different sources all being put together, assembled into this final product. And it's the BOM, the bill of materials, that has the list of, well, you know, all the tires came from this location, this is the serial number, this is the batch number, the battery is from this factory, it was produced on this date, and so on and so forth. And what this can allow you to do, for example, in the event of a failure of some part, let's say the battery fails on a particular vehicle, you can go away and you have a definitive list of which other vehicles have that battery from the same production run, for example, where maybe something has gone wrong. And so you can, all of those vehicles can have their battery replaced at the same time. What is interesting, maybe taking the automotive example a bit further, is that although an automotive manufacturer may have very good information about the hardware within their product, it may well be that they don't have as good information about the software that's running within their vehicle. And this is where the concept of a software bill of materials has come into being. The idea that on any product or within any project, you need a definitive listing of all of the different software components, where they've come from, which version they are, whether they've been patched or changed in some way, and all of that information. And that's what an SBOM, a software bill of materials, is. So taking a car example, you know, you're going to have an operating system that's maybe been effectively downloaded from a project homepage, open source libraries from the project Git repositories, some locally built custom applications from your software teams. Maybe you bought in a user interface from a supplier. And going further, looking at security, you're going to have things like cryptographic keys. Where have they come from? And you may think, surely you know where the keys come from on a product, but there has been a real case where a car owner wanted to update the firmware in their car's in-car entertainment system. And when they tried to do this, they worked through the process. They discovered that the cryptographic keys used to, quote, secure, close quote, I'm doing that thing with my fingers, the device, were actually copied verbatim from an example in a publicly available document. This was in the news a year or two ago. So obviously there was no software bill of materials that said, well, we copied the keys from this PDF that we found on the web. So it starts to become very obvious why this level of information can be very important. So one of the bodies which is very important in driving the uptake of the SBOM, the software bill of materials, is a US government institute called the National Institute of Standards and Technology, NIST. And they've laid out some guidelines of what an SBOM should contain. And so we can see a basic description of that in this slide. So the different data fields. And we can distinguish between what's the minimum requirement, shown in green, and what's recommended as well, shown in blue. So most of these, it's kind of common sense what information you need to know, but it's useful to see it actually sort of written down, as it were. So we need to know the name of the software component and the version with a proper version number. And we need to have some sort of unique identifier to differentiate between different versions. And there are 3 different ways that NIST suggests that could be done. And we'll look at those in detail later on. There's the CPE, the PURL or PURL, and the SWID or SWID. So that's a unique identifier. We need to have some sort of dependency relationship specified within the SBOM. What does this component depend on? What depends on this component? How are the different software components interacting with each other? We need to know where the software component came from, either the name of the actual author or the organization which authored the software component. And then we need a bit of what we could call metadata, I suppose. We need to know what tool was used to create the SBOM data and when was it written. So obviously we need to know that the SBOM data is correct as well. Optionally, but recommended, is to also have a cryptographic hash to allow integrity checking. Information about when the data was captured. Is this data captured from source, during the build, during the packaging process, during the installation process? So that can be termed as a life cycle phase. We may have information about other relationships with other components, like derived from, similar to, things like that. And finally, particularly with respect to open source software, information about the license that the software is released under is going to be very, very useful. So what does this look like in practice? Well, there are different formats, as we'll see later on. But basically what we're talking about is data, lots and lots of data. And it's going to be written in a way which is designed to be machine readable, not necessarily so easy for humans to read, if you like, because we're going to be wanting to make use of tools to create the data, to interpret the data, to make use of that data. So this is an example of a format called Cyclone DX we'll look at later. In XML format, it's actually an SBOM entry for part of the Cyclone DX tools itself, so it's sort of self-referential in that sense. But we can see some of the data that we saw on the previous slide. We can pick out here. We have a timestamp of when the data was generated. We've got the vendor, the name of the device, the component, the version number, a cryptographic hash, which is truncated here to fit into the slide, and then the subcomponents of this product, different component names, versions, licenses, a unique identifier in the PURL Perl format, which we'll look at later. So we can see how the data format is representing the information that we need in our SBOM.
Doulos is a training company providing expertise and specialist training worldwide in all of the areas you can see on screen, from SoC design and verification, FPGA and hardware design, to embedded software and Python and deep learning. Watch the rest of Simon's webinar, What is an SBOM and Why Should I Care, whenever you want, by heading over to our website www.doulos.com/OD and registering for free. For more free tips and tutorials, visit the know-how area of our website, and don't forget to subscribe to our YouTube channel. Thanks for watching.